All right. I made a new poster for IVT. We were simplifying it down a little bit. All right. So the first thing that you have to absolutely show no matter what is that f is continuous. All right. You have to either state or show that f is continuous. All right. The second thing that we're going to show is that k is a number between f of a and f of b. And if you show that k is between f of a and f of b, then you automatically are kind of proving number 2 that they're not the same thing. So we can kind of ignore the second condition there. All right. So you have to prove that it's continuous, and you have to show that the number you're trying to prove exists between your two y values. All right, so let's talk about what the intermediate value theorem is telling me. So the first thing is that it proves a point. All right, it proves a point exists. It doesn't give us a way to find the point. We can just say it's there. We're going to have a couple other theorems in this class that prove other things. So knowing that IVT proves a point is super helpful. And to prove that this point exists, once again, you have to show that you're continuous and that the point you're trying to prove is in between your two y values, which graphically makes sense because if one of my y values is down here and one of my y values is up here and I have a continuous line, then somewhere you will have a point in between all of those y values. Has to be. Okay. Example 41 is 2 parts. It says verify that the intermediate value theorem applies to the indicated interval and then find the value guaranteed by the theorem. All right, so the first part here.
We're going to rate how slow you draw when you're recording.
I'm sorry.
No, I'm saying to you every time.
Oh, yeah. But it's not slow on here, it's just slow. But I'll like write and then I'll look up and it's still writing, yeah.
It's like the lynching.
Yeah.
So you did this last
Mm-hmm.
Oh,
Yep.
yeah,
Yeah.
I literally said earlier we did that last year, did I not?
Yeah, we did. That's why I think it's gone well because it's just kind of a repeat of what we did last year. All right, anyways, moving on. So for proving IVT, the first thing I have to prove is what?
The f is continuous.
F is continuous. And I know that f is continuous. F is right here because it's a polynomial.
Facts.
And all polynomials are continuous.
Do you have to write it out in the steps every time?
State that it's continuous. It's good practice to write because it's a polynomial, but you do need to state it. Like you need to state f is continuous. All right. The other thing I need to figure out are my y values. So what am I going to be plugging into f?
Wait, hang on. How is that not a triangle?
It is, but those are polynomials. Like all
Oh.
yeah. Yeah. So -1 and 2 is what I'm going to plug in to my f function. When I plug -1 in, I get -1 minus 2 minus 1, which gives me -4. And then when you plug,
You're just plugging this into the...
yeah, into the x's here. And so when you plug 2 in, 2 cubed is 8 plus 2 times 2 is 4. So 8 plus 4 is 12 minus 1, which is going to be 11.
So the 2 points right there, it's not an x and a y, it's just an x and an x.
Yes. Yep. So like these points right here, this is like x1, this is like x2.
Period.
Yep. All right. So now that I have figured out my two y values, I'm going to ask myself, what point am I trying to prove exists? The f of c equals 2.
Oh, wait, I was right.
Mm-hmm.
I did this.
2. So is 2 between the two y values I just found? Yes. And so you can write that in a sentence, if you want, like I did on the poster, 2 is between -4 and 11, or you can write it, and I think this is what we did last year, -4 is less than 2 is less than 11. Which this is just the math way of saying 2 is between -4 and 11.
So where are they going to take on the test?
Either one.
You can't just say
No, just less than.
2 is between -4 and
Wait, what?
No.
But you
can't just say
can
stop
write
being
it.
stupid, you know.
No, you have to actually state 2 is between -4 and 11. And so, because it's continuous, because the point you're trying to prove is between the two y values, then we can say that IVT applies and f of c equals 2 exists.
And that's step 3.
Hooray.
That was just proving IVT. So what we just did here, that's probably the more calculus type question that you'll have. All right. Proving IVT, showing that it exists. Those are kind of going to be the questions that you'll see on the AP test. So you do have a lot of test prep questions on your homework today. I definitely look at them because they'll help for the actual test, especially with the way it's worded and stuff. Now for the second part of this question, it says find the value of C guaranteed by the intermediate value theorem. This is algebra. Going back to algebra 2. So where are you going to plug 2 in? Into f of x. So 2 equals x cubed plus 2x minus 1. And if I wanted to solve this, I have to move everything to one side because it's a polynomial, and I have to move everything to one side, and I have to try to factor.
Wait, why are we doing?
Now we're finding c. So we're trying to figure out the c value when it's 2.
So
Yeah.
-1 and 3. No. Yes.
All right. Now, this one is a cubic. It's got x cubed plus 2x minus 3, so it's not your normal factoring trinomial method, right? And we're not going to do it because it's kind of a pain in the butt to do. But you would factor and solve. You'd have to use the rational root theorem on this one. That's why we're gonna just move on. Algebra 2, I don't even care. What you need to know more is the calculus. And on the AP test, I think back in like 2020 or 2021, they tried to revamp the test where it is more calculus, less algebra. So you're gonna ask all kinds of wordy questions about IVT and what it takes for it to stuff to exist and all that stuff. But they're not going to ask you to find it. That's algebra. They don't care if you know algebra. They want to know if you know the calculus. Do you know the theorems, okay? So we don't care if we can do that or not, all right? You might have to solve, for sure. You are going to have to solve at some point, but they're not going to be really, really complicated algebra 2 solving, all right? We need to know the theorems. You need to know the words. All right, moving on. Yeah, if you do come across a solving question like this, a lot of times it is a calculator question, which remember you plug the left side in Y1, the right side in Y2, figure out where they intersect. So a lot of the solving stuff is on that part of the test. All right, moving on. So 42. Use IVT to show that f of x equals x cubed plus 2x minus 1 has a 0 on the interval 0 to 1. So what is the first thing you got to show is that f of x is continuous.
What would be an example if it wasn't continuous?
If it has a jump, a hole, or a BA. So if you have the rationals,
It's a fraction, and then you can
yeah,
then
like
you can't do it at all, right?
right, then this doesn't apply if it's not continuous, or like piecewise. So a lot of your functions are going to be continuous. All right, so the second thing, we got to find our y values. So what are we going to plug into the function?
0 and 1.
0 and 1. When you plug 0 in, what do you get? -1. When you plug 1 in, 1 plus 2 minus 1? 2. All right, now what are you trying to prove exists?
0.
A 0.
It does.
It does.
Yay.
Yeah, so we're trying to prove that there's a 0, which means the number 0 exists. Is 0 between -1 and 2? Yes, so -1 is less than 0 is less than 2. So IVT applies, or we can just put, hold on. You could write it that way, that's fine.
Like, that's your answer.
I'm gonna say, wait. So yes,
Yes.
f of x has a 0 by IVT. Or you can put IVT applies, so f of x has a 0. Just answer the question, so make sure you actually answer it with like a yes or a no, or yes there is a 0, or a 0 exists. Like, don't just put the stuff and don't answer the question. Answer the question with a sentence or some words, and then reference IVT. What's up?
I said f of c equals 0. Is that gonna be wrong?
Nope, that's fine.
What part do we circle as our actual answer?
Don't circle anything, just have all the work there. All right, next one. So the table above shows selected values of a continuous function from 0 to 13. What is the fewest possible of times that f of x can equal 4? So this is kind of like a common sense question, but this is IVT. So it is on, I've seen multiple questions that look just like this on the AP test, and you would be amazed about how many people get them wrong. So first of all, we're continuous. And I want to know if we have to hit, how many times we have to hit 4. So do you have to hit 4 from 3 to 4.5?
Yes.
Yes. What about from 4.5 to 3? Yes. What about from 3 to 2.5? No. What about 2.5 to 4.4? So what's the fewest number of times you have to hit 4? 3. All right, 3 times. If it doesn't say justify, you do not need to worry about writing all your steps. But if this one said justify your answer, you would say f is continuous. And then you would say 4 is between 3 and 4.5. 4 is also between 4.5 and 3. And 4 is between 2.5 and 4.4. So it would have to hit 3 times, something along those lines. So if it says to justify, just put all of my explanation. You just put it out in words. Okay, 44. Let f be a function that is continuous. So once again, we are continuous here. On the closed interval 2 to 4. With f of 2 equaling 10 and f of 4 equaling 20, which of the following is guaranteed by the intermediate value theorem? All right, so remember I told you that we're going to have 3 different theorems, and they're all going to prove different things. What does IVT prove? A point. Proves a point. So it's not a maximum. We are not proving a maximum. We are proving a random point exists.
It couldn't be f of 3, right? Because it would be f of x.
Right. We don't know that it's at 3. Does 15 exist between 10 and 20?
Yeah.
Yes. But we don't know that it's at 3. Yeah. So that one is also wrong because it's too specific. I know 15 exists. I don't know that it's at 3. And then for A, does 13 exist?
Yes.
Yes. And it's f of x equals 13. So it's general. We just know it exists. We don't know where exactly. We just know it's there. Okay, and then my last question here. I have a car. He travels on a straight track. During the interval from 0 to 60, the car's velocity v is measured in feet per second. Acceleration is measured in feet per second per second. They are continuous functions, which this tells me that I can use the theorems. The table above shows selected values of these functions. From 0 to 60, must there be a time when v of t equals -5 and justify your answer? So we got to justify. So what's the first thing we have to prove?
It's continuous.
What specific function do I want to prove continuity for?
0. Yeah.
V of t. All right, because I've got v and I've got a, but which one am I concerned about? V. Because I'm trying to prove a point on the velocity graph. Does that make sense? Okay, so v of t is continuous, and I know that because it's given. You don't have to write given, but just because they're notes, that's where I'm getting that information from. All right, so I actually don't care about acceleration at all because I'm trying to prove a point on velocity. Okay, so now what point are you trying to prove exists? -5. And is -5 between -20 and 10?
Yes.
Yes. So my second part here is -20 is less than -5 is less than 10. So, yes, V of t equals negative 5 exists by IVT. All right, you have your two conditions for IVT. You have to show continuity. You have to show that your point is in between your other points. And then you can answer your question and reference your theorem.
Hooray.
All right, y'all feel good about IVT?
Yeah.
All right, let's look at your homework real fast.
Oh, it's all.
I know it looks like a lot.
It is a lot.
It is, but
I tried to, yeah, there's a lot of test prep questions. So I tried to like shorten it, but the test prep it's just good review for like your tests that you're going to have in the AP test. So I left it on there.
Okay, so test prep questions are for the AP test, not our tests?
Both, because your tests are from old AP tests.
can
Oh,
I turn it's freezing
Yeah.
in here.
All right, so I'm going to do some of these questions with you. The first three questions are very similar, so I was going to do one with you, and that way you only have to do the other two sections. So on the interval from negative 5 to 1, must there be a value such that f of x equals 30 and explain? All right, because it says explain, that's my justification. So the first thing I need to prove is that f of x is continuous. And how do I know that it's continuous?
It gives it.
Yeah, it gives it right up here at the top. It gives it. All right, so then I'm going to look at my interval from negative 5 to 1. So I'm not talking about the whole table. I'm just talking about from negative 5 to 1. So be careful about that. So from negative 5 to 1, do you have to hit 30? Yes. So I'm going to say 7 is less than 30 is less than 40. So yes, by IVT. All right, so we're continuous. The point is in between my other 2 points. So yes, it has to exist. All right, so number 2 says, could there be a value? So now we're talking about from 3 to 8. So from the interval from 3 to 8, could there be a value for f of x equaling 100? Could there? Could there? Do you know it exists?
No.
No, we don't. But could it? Could it exist? Yes. So the could there is important. So yes, we don't know what happens between 21 to 75. All right, it does not have to go like a linear pattern. It could go to 21, it could go to 1,000, and then 5,000, and 200, and negative a bajillion. We don't know what happens between 21 and 75. It could hit 100. We just don't know. Okay, on number 3, what is the minimum number of zeros?
2.
So then, and we're talking about from negative 5 to 14. How many? 1. Because you have to hit,
75 to negative 100.
yeah, from 75 to negative 100, you have to hit 0 at least once. There could be more, we don't know, but there has to at least be 1. All right, from 1 to 14. So from 1 to 14, what's the fewest possible times you would hit 20?
2.
Are you sure? I think it's just 1. Because, okay, so we're not starting here. So 40 to 21, do you have to hit 20?
Oh yeah, it's just 1.
Yep, nope. 21 to 75, you don't have to hit 20, but 75 to negative 100, you have to hit 20. And then the last one here is from 1 to 8. What's the fewest number of times you'll hit 7? 0. You don't have to hit it any times.
Wait, so what the answer is 2? No, it was 1.
It was 1. 1, 1, 0. All right, does that make sense? Okay. I want to do number 5. All right, right before the test prep, I want to do number 5. Because you have a couple other ones that are similar to that one. So it says, let f be a continuous function such that f of 0 equals 2, f of 3 equals 0. And let g of x equal x minus f of x. All right, so I've got g right here. And I've got these 2 points right here. Don't waste my staples. Explain why there must be a value k from 0 to 3 such that g of k equals 0. All right, so what's the first thing I have to prove? What is continuous?
G.
Yes. G of x is continuous because the point you're trying to prove, is it on G or is it on F? G, you're trying to prove G of k equals 0. So we're trying to prove a point on G. So the letters matter. So first we have to say G of x is continuous. The second thing you have to prove is that your y values are different. So in to G, what are you going to plug in? 0 and 3. Okay. So remember, your G function's right up here. So I'm going to plug 0 in. So I've got 0 minus f of 0. What is f of 0? 2. So that's going to all be negative 2. And then I got to do 3. 3 minus f of 3. And what is f of 3? 0, which is going to be 3. So what number am I trying to prove exists? 0 is 0 between negative 2 and 3?
Yeah.
Yes, so does it exist?
Yeah.
Yes. So negative 2 is less than 0 is less than 3. So yes, by IVT. Does that kind of make sense? IVT? Okay. We're going to review tomorrow. We're going to review for the beginning of class on Thursday, and then you'll do the calculator part of your test Thursday, the rest of it on Friday. All right, homework and all of that is going to be due.